Hey guys, I'm going to be doing Simple Solutions lesson number 42. So if you can go ahead and grab that, we'll do that together. For number 1, we will be rounding. Our original number we're rounding is 464 and 646 thousandths. We'll be rounding to the nearest hundredth. The digit in the hundreds is this 4. Neighbor is a 6. 4 or less or 5 or more. This will be 5 or more, so we'll go up one more. 4 will turn into a 5. Everything in front stays the same. Everything behind zeros their name. So our rounded number is 464 and 650 thousandths. Number 2, we will be doing estimation first, and then we will find the exact. For 7 5/10 divided by, this one's a difficult one, 5/10. So if we were rounding this, 7.5 would round to 8, because if you had a number line with 7 and 8, and if I had 7.5, when you have that 5, you round up. Same with 4 less or 5 or more, that 5 and the 7.5 will make us round up. So we would round to 8. And same thing with a half. You would have a 0 and a 1. If we were to plot 5/10 on there, that would be 4 less 5 or more, which then would go up to 1. So then we would have 8 divided by 1. That one's a little bit more simple because we know of 8 divided by 1. So let's go ahead and do exact. So first we're going to move these decimals. If I move my decimal once to the right on one, I have to do it to the other as well. So then that would make it 75 divided by 5. So if you don't know that, skip count by 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, which would be 15 times. Oh, I have no idea what I just did. I think I did it. There we go. 15 times is what we had said. All right, so then 8 divided by 1 would be 8. So it is a pretty big difference between our answers on this one. But the main reason for that are those decimals that were in our exact answer. All right, so let's go on to number 2. It says convert 2 kilometers to meters. So 2 kilometers equals, I'm going to put blank and put meters. So first we have to think of, well, what is 1 kilometer into meters? So if you have your conversion chart at home with you, go ahead and get that out. If you do not have your conversion chart, don't worry, I pulled one up. So right here, it's asking about meters, how many meters are in a kilometer. So it's right there, that first one where it says metric. So 1 kilometer equals 1,000 meters. So let's go back. 1 kilometer is 1,000 meters. So in order to find out how much 2 kilometers are in meters, then we would multiply the 1,000 and the 2. Well, 1,000 times 2 would be 2,000. So 2 kilometers is 2,000 meters. It says, will the converted amount have more or fewer units than the original? Well, units, it would end up being the same amount of space because you are finding equivalent, mainly because of this equal sign. So if we were to line up 2 kilometers and then right next to that line up 2,000 meters, neither one of those would have more. They would be the same. So I would put same. All right, for number 4, choose the numerical expression that represents subtracting 831 from 1,722 and then dividing by 1/2. So when you are doing this, let's first look at subtracting 831 from the 1,722. So does A, is that subtracting those? It's not, so mark it out. B, is that subtracting those two? It's not, mark it out. C is subtracting. Now let's go ahead and double check and make sure the wording goes with this dividing by 1/2. It does, dividing by 1/2. So C would be your correct answer. 5, we have 27 multiplied by 35. We're just going to write this vertically. So let me change the colors of my pen so I can kind of help you visualize. 7 times 5 is 35. 2 times 5 is 10, plus the 3 is 13. We are going to put in that place value 0. And I'm marking out this 3 because we will no longer use it for this next section we're multiplying. So 7 times 3 is 21. 2 times 3 is 6, plus 2 is 8. We will now add. 5 and 0 is 5, 3 and 1 is 4, 1 and 8 is 9. So 27 times 35 is 945. Number 6, the area of a rectangle is 56 inches squared. The length of one of the sides is 7 inches. Find the width and label your answer. So I'm going to actually just draw a rectangle in here. It says, I know one side is 7 inches, so I'll put 7 here. Well, if this side is 7 inches, this side is also 7. So we're looking for this long side here. So we know area is length times width. The reason I use that cursive L is because if I were to use a straight L, this really looks like the number 1, which is not what we want. So I use that cursive L. So if I know area is 56 inches, I'm going to put 56 in place of that A, which stood for area, equals. Length could be that 7, but now we're going to be looking for that W. Well, 56 equals 7 times W. Well, 7 times what gets you 56? Well, I know 7 times 7 is 49. So if I add 7 to 49, that does get me to 56. So that would mean that would equal 8. So that width would equal 8. Well, instead of just saying 8, 8 what? 8 inches, 8 feet, 8 pineapples, 8 what? It would be 8 inches. So right here is your answer. The width is 8 inches. All right, let's go ahead. I have a second one. We're going to do 7 through 12 on this side. All right, so number 7, it says complete the next shape in the sequence, describe the pattern. So it went from going up to the right, straight in the middle, up to the left, straight in the middle, down. So then it would be straight down. So if you just draw a straight down area, it's basically rotating to the left, rotating, rotating, rotating. All right, number 8, solve 1,350 divided by 75 using an area model. See the help pages for an example. All right, so we're doing 1,350 divided by 75. You guys know I like to just write the problem down just to be safe. All right, guys, so I write pretty large, so I'm going to redraw that little box that they have. It's a little wonky, but that's okay. I'm going to actually go back and redraw my lines. All right, so we have 1,350 or 1,350, and we are dividing this into 75. Now, we have not done this together as a class, so I actually brought up the help pages. So if you have it, this is a very lengthy explanation. I'm not going to go over all of that with you, but if you need more of an explanation, I would definitely refer back to this in your Simple Solutions help pages. So let's go back to this really quickly. What you're wanting to do is basically try to break down into smaller sections of the division equation. So we're dividing by 75. So the first thing I think always is multiply by 10. Like, so if I had 75 times 10, I know that that's 750, and I do have at least 750 in this 1,350. So I'm going to do this. So that would be 750. So if I took that out, because I need to know what's left, 0 minus 0 is 0, 5 minus 0, or 5 minus 5 is 0, and then 13 minus 7 is 6. So 600 is what I have left. So I need to see how many 75s will go into 600, because I knew 10 75s made 750. So I took that 750 out, leaving me now with this 600. So how many 75s are in 600? Well, I do not know that right offhand. So what I'm going to do is do some multiplication over here and do like 75 times 5. See what I get with that. 5 times 5 is 25, 7 times 5 is 35, plus the 2 is 36, 37. So 375. I have that. I have enough for 375 to be in that 600. So I'm actually going to put 5 here. And the 5 times the 75 we said was 375. So let's take that away from the 600. Well, we have to go through and we have to 10 would be 9. Go here. 10 minus 5 is 5. 9 minus 7 is 2. 5 minus 3 is 2. So now we have 225. So this right here was 375. Well, I still have 225 left. So how many 75s will be in 225? Well, I know 5 times is too much because that got me to 375. So I'm actually going to go down not once, because I know taking 75 from that 375 would be 300. So I'm going to do 75 times 3 and see what that gives me. 5 times 3 is 15. 7 times 3 is 21. Plus that top one is 22. So boom, it was 3 times. And 3 times that 75 was that 225. So if I were to subtract that, that would get me that 0, which is what I needed. So now we have to add all of this up. So 10 plus 5 plus the 3 gets me to 18. So if I were to ask you what 1,350 divided by 75 was, you would say 18. So this is using the place value model. Now, does it work with everyone's brain? No. But some of your brains, possibly. So this could be a strategy you can put in your brain and use for a later date. Number 9, find the lowest common denominator. So remember, sometimes people try to refer to lowest common denominator as LCD. Replace the given fractions with an equivalent form and then add. Write the answer in simplest form. So our original equation is 3/4 plus 1/3. That's a plus symbol. So what we always have to remember is your denominators need to be the same in order for us to add them. Well, they're not. One is fourths and one is thirds, but they've already told us what they want the denominator to be. They want it to be twelfths. So we have to convert or change our denominators to an equivalent fraction that has twelfths. So let's do our 3/4 first. So we want this to equal with a denominator of 12. Well, 4 times what gets you to 12? Well, that's 3. Whatever I do to the denominator, I have to do to the numerator. So 3 times 3 is 9. So my equivalent fraction is 9/12. So now let's do the 1/3. We want this to also have a fraction with 12. So 3 times what will get you to 12? That would be 4. Whatever I do to the denominator, I do to the numerator. So 1 times 4 is 4. So my equivalent fraction for 1/3 is 4/12. So now if we were to add, sorry, I zoomed in hardcore. My hand will randomly, now it's too tiny. I can't do a happy medium. Okay, so now if I do 9/12 plus 4/12, your denominators will stay the same. And now we will add the numerators. 9 and 4 make 13. So 3/4 plus 1/3 is 13/12. Yay, good job. All right, number 10, shade in 80 hundredths of the fraction model. Write this fraction as a decimal. So inside of this base 10 block, there are 100 pieces. And a column is 10. So if I have 80, I will be shading in 8 columns. Remember, this does not have to be beautiful, just as long as you get the gist. And then the fraction is 80 hundredths. But to write this as a decimal, you would be decimal 80 hundredths. tenths. Number 11, which shape has a perpendicular side? So perpendicular, remember, is a perfect plus sign somewhere in which all four of these angles would be 90 degrees. Now, one side could be really long or another side could be really long, but as long as you have this plus symbol somewhere, that's where it would be at. So what it's wanting to say is to say, oh, say that this, let me zoom in so we can see a little better. Say that all of these sides just went on forever and ever and ever and ever and ever. Somewhere they want a perpendicular line. Well, that's not it. That one's not it. But say that I stretched out the lines of this square. Boom, perpendicular lines. Boom, perpendicular lines. So this one is a definite. Now, if we were to do this, would there be any perfect perpendicular lines to create 80-degree angles? Or 90-degree angles? That's a no. Now with this one, if we stretched out all of these, would any of these create perpendicular lines that created 90-degree angles? No. So the only correct one is your square. All right, let's do number 12. We have 5 and 5/10, and then we have 5 and 97/100. So when you are, let me do a different color so you can keep track of where we are, because I'm going to write over here on the side. So if we have 5 and 5/10, I'm going to line up my place values. So 5 is in the ones, this 9 is in the tenths, and this. So if we're going to compare anything, we have to start with the largest place value, which is your ones. Well, they have 5s in the ones, so that's a no. So my next largest are my tenths. I have a 5, I have a 5 and a 9. So the 9 is larger. So 5 and 97/100 is the largest. So if you do the alligator, your alligator would eat that number, but you also have to know how to say it. So it would be 5 and 5/10 is less than 5 and 97/100. All right, let's do our last three. Number 13, we have 542, it's 216 in parentheses, divided, I do believe that is a division symbol, divided by 471 minus 345. This is order of operations, which we know as PEMDAS, or please excuse my dear Aunt Sally. P is parentheses. We have two sets, so we have to do 542. I'm going to come down here so I'm not right underneath that one. So we were to add that, 2 and 6 is 8, 4 and 1 is 5, 5 and 2 is 7. So we will replace that with 758. Now let's do 471 minus 345. I cannot do 1 minus 5, so I have to go borrow. 11 minus 5 is 6. 6 minus 4 is 2. 4 minus 3 is 1. So we'll replace this with 126 divided by dun dun dun. All right, so this one's a little bit more intense than what we've ever had. Let me go and make sure that this was supposed to be division before I go through with it. All right, so I went and looked at my key and it is actually a plus symbol. So disregard. So now let's just add these two. 758 add 126. 8 and 6, I think of 6 and 6 is 12, plus that extra 2 is 14. 1 and 5 is 6. 6 and 2 is 8. 7 and 1 is 8. So our answer would be 884. Number 14, state the rule, then write the next two terms. So we are going from 56 to 73 to 80, and then we have to do our next two terms. I'm going to leave some blanks. So my numbers are getting larger. So there's two operations I can use to make a number larger in 5th grade, which are addition and multiplication. Well, I know this is probably not multiplication, so let's look to see how much we have to add. So 56 plus what will get me to 73? Well, I'm going to do the opposite operation of addition, which is subtraction. So I'm actually going to do 73 minus 56. Let's see what I get there. So 13 minus 6 would be 7. 6 minus 5 would be 1. So here they have added 17. Well, let's see if 73 plus 17 would get me to that 80. 3 and 7 is 10. 1, 7, and 1 is 9. So then that one did not add 17. So with this one, it was not 17. So let's see how much we have to add to 73 to get to 80. Well, I'm just going to count out loud because that's close. So 73, 74, 75, 76, 77, 78, 79, 80. So that was actually adding 7. So this has two rules or two different operation rules. So one was adding 17, then add 7. So if we added 7 last, the next thing we would do is add 17 to that 80. So 80 plus 17, 0 and 7 is 7, 8 and 1 is 9, so 97. And then we'll add 7 to 97. 7 and 7 is 14, 9 and 1 is 10, so the next one will be 104. So you need the rule in the next two terms. Okay, let's do 15. If two shapes are congruent, they have exactly the same size and shape. Which polygons are congruent? So exactly same size, exactly same shape. So I automatically notice C, and I think the reason is because it has 1, 2, 3, 4, 5, 6 points. So I'm going to write a little 6. This has 1, 2, 3, 4, 5 points. 1, 2, 3, 4, 5 points. 1, 2, 3, 4, 5 points. All right, so yeah, that's a no-go on C because there's nobody else that has 6 sides. All right, and then when I'm looking at A, B, and D, I notice that A is a little fatter. I guess I didn't know another way. Whereas B and D look the exact size shape. So I'm going to say B and D are congruent because they have the exact same size shape. I can having a hard time saying that. So B and D. All right, good job today.